Alright, this is our last set of notes for this unit. It goes some with the 8.5 worksheet and some with the 8.6 worksheet. So we're going to talk about rational versus irrational numbers. Some of you may have heard of rational versus irrational. We're going to talk some more about it today. So rational numbers are numbers that can be written in the form a over b, where a and b are integers. That's the formal definition of it. Informally, rational numbers are whole numbers, so they're integers. So let's see, e.g., in other words, for example, rational numbers are integers, they are fractions, fractions that are terminating decimals, fractions, they are terminating or repeating decimals. So in the example here, we've got some radicals, but they are all perfect squares, so they simplify to whole numbers, which are integers. Specify there, integers are whole numbers. Okay, one sec. Let me fix my here so I can write a little bit better. Okay. So integers, which are whole numbers. Okay. So that's rational numbers. Integers, fractions, terminating or repeating decimals. Irrational numbers are any numbers that cannot be written in the form a over b, where a and b are integers. All that to say, here's a bunch of examples of irrational numbers. What you'll notice in the rational numbers, right, we've got some radicals like the square root of 9 or the square root of 4 or the cube root of 27 that all simplify to be whole numbers. In our irrational numbers, we have the square root of 2, square root of 13, square root of 18. We have radicals that cannot simplify to be whole numbers. We also have pi. Pi is irrational because pi is a non-terminating, non-repeating decimal. Terminating means to end, right? So irrational numbers are any imperfect radicals or they are non-terminating, non-repeating decimals. Actually, I'm gonna erase that guy. Okay, so non-terminating means it never ends, right? So like in rational numbers, 1/4 as a decimal would be 0.25, right? That ends. That is a terminating decimal, so that is a rational number. A non-terminating, non-repeating, that's like pi, right? Pi goes on forever and it never repeats itself, so it is an irrational number. Okay, so basically anytime we can get rid of our radicals, it's rational, but if we can't get rid of our radicals, then it's irrational. So that's mainly what we're dealing with in this section. So simplify the radical expressions and then write if the answers are rational or irrational. So when we're adding or subtracting radicals, they act like variables, and I've said this before, which means that the terms have to have the same radical in order for us to add or subtract them, and then when we add or subtract them, the radical doesn't change, just the number in front does. So when we have 5 root 7 minus 8 root 7, because they both have root 7s, we can combine them, and that would be 5 minus 8, and then the root 7 stays the same, right? It's like if we had 5x minus 8x. That would be negative 3x, right? It's going to act the same like that. 5 root 7 minus 8 root 7 is going to be negative 3 root 7. So there's our simplified expression. Same kind of idea here, the 3 and the 5, so we can't combine the 3 and the 4 root 19 because the 3 doesn't have a root 19. But we can add the 3 plus the 5 and we get 8. and then we can add the 4 root 19 and the 2 root 19, and we get 6 root 19. And we can't simplify the square root of 19 any further, so our answer is 8 plus 6 root 19. So then on both of these, because in both of our answers we still have those imperfect radicals, root 19 and root 7, both of these answers are irrational. As long as we still have an imperfect radical, it's going to be irrational. And the next one we have 4, and then we have this 4 plus 4 root 3, and then we have minus and in front of the parentheses here, which means that we need to distribute that negative into both of these terms inside. So we're going to have 4 plus 4 root 3 minus 2 minus 3 root 3. So we can combine the 4 and the minus 2, and we get 2. And then we can combine the 4 root 3 and the negative 3 root 3, and we get plus 1 root 3, or just plus root 3. And this is irrational because it still has that imperfect radical. Okay, next one, same process. We've got a minus here, which we need to distribute into our parenthesis. So we're going to have negative 7 plus 5 root 7, and then we're going to have minus 3 and minus 2 root 7. So the negative 7 and the minus 3 we can combine, we get negative 10. And then the plus 5 root 7 and the minus 2 root 7 we can combine, and we get plus 3 root 7. And this is still irrational because we still have that imperfect radical. Okay, and then the next one we have 5 root 7 times 2 root 7. So we've done some problems like this before. When we have a radical times a radical, we're going to multiply what's in front and then multiply what's underneath together. So we're going to have 5 times 2, which is 10, and then root 7 times root 7 gives us root 49. But then that root 49 we know is a perfect radical here, simplifies to 7. So 10 times root 49 becomes 10 times 7, which is 70. So on that one, we got rid of our radicals, right? We ended up with a whole number, an integer. So this answer is rational. Okay, on the next one, we have same type of problem. We're going to do the negative 3 times the 4. That gives us negative 12. And then root 3 times root 7 gives us root 21. 21 factors to 3 and 7, which we cannot break up any further. So this is a simplified radical. So our answer is negative 12 root 21, which is irrational because we still have the root 21. So again, as long as we have an imperfect radical in our answer is irrational. Okay, on this one, a couple different ways we can go about this, but I'm going to go ahead and simplify this root 12 first. So root 12, I'm going to split 12 into 4 and 3, split 4 into 2 and 2, and it's a square root, so I'm looking for buddies. So the square root of 12 simplifies to 2 root 3. So I already had this 4 out in front, so when I bring my 2 out, it's going to get multiplied with that 4, and on top of my fraction, then I'm going to have 8 root 3, and then on the bottom of my fraction, I still just have the root 3, and then I see I have root 3 on top and on bottom, so they cancel each other out, because when we have a factor on top and bottom of a fraction, they simplify, so this simplifies to just 8. Which is a whole number, so our answer is rational. Okay, now what we'll notice there is 12, well, never mind. Scratch that. If you want to try to find another pattern to do that, you can, but I'm just going to keep doing it the same way. Okay, so same thing here. I've got root 75. I know I can simplify that. Root 75 simplifies to 25 times 3, simplifies to 5 times 5 times 3. So again, square root, I'm looking for buddies. One of them dies, one of them breaks out. So the square root of 75 is equal to 5 root 3. But I already had the 5 out in front of my root 75. So when I pull this 5 out, it's going to get multiplied with that one. And I'm going to end up with 25 in front of my root 3, and that is over 3 root 3, which is still on the bottom of my fraction. So again, I have root 3 on top and on bottom, so they cancel each other out, and I'm left with just 25 over 3. 25 over 3 is a fraction, so this is rational. So I actually had erased fractions up here, but I'm going to put that back in because we're not going to see any fractions that are irrational, I don't believe. Okay, so rational versus irrational, long story short, is if it still has a radical that you can't simplify any further, then it is irrational. If it doesn't, then it is rational, unless it's pi. Okay, so complete each sentence with always, sometimes, or never, and then list some examples to prove your choice. So our first one, a rational number plus a rational number will blank equal a rational number. So this is saying if we have 4 plus 6, we will always get an answer that is an integer, right? Or even if we have a fraction plus another fraction, we will still get a rational number. Is there any way to add rational numbers to get irrational numbers? No. So as long as we have a rational number plus another rational number, we'll always get a rational number. A rational number multiplied by an irrational number will blank equal an irrational number. So an irrational number, right, is an imperfect radical. So if we have root 3 times a rational number, say 2, we'll get 2 root 3. That's irrational. Okay, so if we have root 2 times 5, we'll get 5 root 2. Okay, that is to say, there's no way, well, except for there's one special case, and this special case kind of breaks a lot of these statements, per se. Okay, there's one rational number. If we take 0 and multiply it by root 2, we'll get 0. 0 is rational. So this answer is sometimes, most of the time, we could even say. Okay, because these are all examples of when it does happen, so this makes it true, but 0 is a counterexample. So I guess I'll just call it false, right? But this is going to make a rational number multiplied by an irrational number rational. This is going to make it irrational. These are irrational answers. 0 is rational. So logic statements, sometimes they're confusing. Rational number raised to a 0 power will blank be equal to 0. What is anything raised to a 0 power? 1. This is never. Even if you have 0 and raise it to a 0 power, it's still 1. Fun fact. So a rational number raised to a 0 power will never be equal to 0 because it's always equal to 1. And then last one, an irrational number multiplied by an irrational number will blank be an irrational number. So if we have two irrational numbers, say root 3 and root 2, we multiply them together, we'll get root 6. Root 6 can't be simplified at all, so this would be an irrational answer. This would make this statement true. Now try a different one. Root 5 times root 7. If root 5 times root 7, we get root 35. Again, can't be simplified at all, so this is also an irrational answer. However, what happens when we do root 2 times root 2? That gives us root 4, which is 2. That is a rational answer. So anytime we take a radical, which would be an irrational number, anytime we take it and multiply it by itself, we get a rational answer. Because of that, that makes this blank sometimes. An irrational number multiplied by an irrational number will sometimes be an irrational number. Okay? So jot down some notes, ask some questions, and then we'll be able to do our 8-5 or finish the 8-5 worksheet and do the 8-6.